morning, everyone. I'm Nathan Bembo, Engineering Design Manager at ASH. For those that don't know of ASH or haven't heard of us or want to know more, we are Australia's largest vertically integrated hardwood processor by a long way in Australia. We have our main green mill and dry mill and manufacturing facility in Hayfield in East Gippsland in Victoria, and also our second sawmill down in Western Junction in Tasmania. And we have currently nine separate manufacturing lines that go into manufacturing various products such as stair components. We use currently sort of three main timber species, being Tasmanian oak, plantation oak, and we are the largest importer of American oak as well. And we're continually looking to diversify fibre resource and looking at opportunities there. So yeah, stair componentry, lining, cladding elements, window architraves, these sorts of elements that can go into beautiful architectural homes, the likes of this. And then we also have our Masslam product range, which essentially is our glue laminated timber product. ASH has one of only two, maybe three now, of the largest Hundegger CNC machines in the K2I. We have a second one in a speed cut, and we're bringing online our third with a Robot Max at the moment. These products go into projects like this. Beautiful showcase of architectural elements, post and beam structures. I'm just skipping through this very quick because lots to talk about, and obviously focus on PCC, skylight or roof structures, as mentioned by Kylan, the Westfield Knox in the introduction. Fit out structures, another roof example. Wellington Street or T3 Collingwood, which is just topped out structure just this past week. So that's all going along nicely. UTAS, an example here, really highlighting the ability to pair the structural components in the Masslam with our other products that we produce and deliver to the market. And I mentioned plantation oak. So really at the moment, we are looking to, next year, our target is to double our capacity and the volume that we supply the market in the mass timber space. And one of the big ways we're going to do this is with our plantation oak. So that's plantation coming out of Tasmania. And the other way is what we're all here to talk about today, which is ASH's Timber Concrete Composite system, which we call Advanced Timber Composite, or the first iteration at least is, or ATC for short, which is our Timber Concrete Composite panel. So it's a ribbed type system, as you can see here, the Masslam element or beams going in as joists. We have lost formwork with a Tassie oak ply, and then the concrete topping. So this will allow us to actually deliver an expressed timber soffit as a flooring system. And the reason that we're exploring this and see a lot of merit in it is the fact that we can achieve longer spans. So achieving sort of grids, the likes of conventional steel and concrete structure, which means we can eliminate transfer slabs. It also means you're putting in less members by spacing them out, which is fewer lifts on site. So that should aid speed of construction. You're also enlarging the area for trades to work in, also to handle materials and everything. So it's easier to move around sites. So there's those advantages. Service reticulation. So there's opportunities to actually reticulate services between the joists here, which I'll highlight again at the end with the RMIT garden building, just showing that. So that's a huge benefit. We can eliminate sort of penetrations through primary beams and things like that, which are very costly and costly because of how long they take to CNC. Also just, can be challenging to satisfy structurally from a performance perspective. So with ATC2, it's worth mentioning we've just gone through the bulk of it. We're wrapping up all of the testing and everything, or reporting on the testing that's being done as part of a NIFBI project for ATC and Timber Concrete Composites in general. That will ultimately go into a WoodSolutions design guide, I believe. And through that, we've achieved 2-hour fire rating for this system, which means that we'll be able to offer a deemed to satisfy fire solution with the express soffit, as I mentioned. So that's great. Whereas current systems, the likes of CLT, particularly in Victoria, and I know that other states are moving in a similar way, where the fire strategy and fire safety sort of strategy means that you need to encapsulate CLT to prevent delamination and to achieve sort of burnout, so to speak. Whereas, we won't have that issue with this solution. There's also enhanced acoustic performance, so less materials as well, which aids sustainability, and also speed of construction and costs, taking that out. Enhanced vibration performance, so sort of greater stiffness and also greater damping due to the introduction of the concrete. And then enhanced durability and water management on site, which is really critical, as I'm sure everyone attending is aware of. This gets talked about at nearly every sort of lots of webinars or seminars and conferences related to mass timber. It's really, a lot of work is going into that to work through ways to manage water on site. Whereas these sorts of solutions, provided the concrete is actually poured on site and you have that sort of consistent surface and you eliminate all of those joints between cassettes, this will go back to sort of well understood conventional type approaches for water management, which will help mitigate those issues. This ribbed type solution is quite an efficient use of timber fibre, which is really important. So I actually did some calcs with for an equivalent CLT panel using 12,000 MPa as the modulus of elasticity. So not trying to skew the results, so to speak, with a lower grade CLT. So the higher end in terms of its stiffness capabilities, and we're able to actually pull out around 60% of the fibre required for the timber, which means it can be used for more projects in other ways. So just aiding that sustainability, rather than just then claiming higher sort of carbon sequestration by having more and more timber in there. It's still important to have efficient use of material. So very sustainable solution. Just another image there. This is my attempt at doing a bit of a render. We are in the process of getting some professional renders done, but gives you an idea there. And I've put in sort of the two sort of options, the joist running over the top, which will really facilitate good surface reticulation on the sort of left-hand side here, and the right-hand side having it in the same plane, which means obviously smaller floor-to-floor heights. You can still look to conceal your surfaces for the most part between those joists, but there will be means or a requirement to reticulate in more conventional ways with that method. And there's the opportunity to do something in between. So sort of notching joists to have partial penetrations through. Obviously, you need to work through blocking requirements from a structural diaphragm perspective, load transfer, and also any acoustic requirements and fire if they're on compartment lines. Just thought I'd share this. So we're actually in the process of constructing our own prototype essentially at our retail centre in Hayfield. So this is a little mezzanine that we're building. Shot drawings there. So we are actually doing this. This isn't all sort of pie in the sky stuff. There's lots of work that's gone into developing this system, and we're actually implementing it. And we have projects underway that are in design at the moment with this. So you can see here, and this will allow us to actually really take clients through, or any project stakeholders through, and they can see it and see opportunities in it, hopefully at early stages, so that this sort of alternative scheme compared to conventional mass timber sort of arrangements can be considered early on. Fire, as I mentioned, so we've achieved 2-hour fire rating through the testing. See there. Acoustic testing as well is being undertaken. So in the commercial space, we're likely to see sort of that bare solution, or very pared back solution with minimal build-ups on top of the floor, and obviously there's also abilities to increase the acoustic performance for the residential market too, either being additional material on top or if absolutely required, with suspended ceilings, which is no different to what's usually required in all other applications and materials anyway. So, but for the most part, in the commercial space, we will be able to have that express soffit. So to just timber concrete composites in general, there are the sort of the ribbed type systems. There are the panelized systems that use a variety of different mass timber solutions, CLT, DLT, NLT, and then a whole suite of shear connectors and ways that that's integrated and tied together, which I'll touch on. Just a couple of photos here. I thought I'd just chuck in a couple of AI generated images that I did. Couldn't figure out the prompts to get a ribbed solution to come through in this form very well, but did manage to get it in the overall appearance. And I think the one on the left was my very sort of first attempt with a prompt at that. It did pretty well, besides that concrete column that's being suspended in the middle. But yeah, we might be able to use this for marketing very soon. And so I'd include those. Design methods. So just quickly to highlight a couple, there's a vast array of information available out there, but I'm sure these names won't be new to anyone that's had any sort of time in the timber space, mass timber space in particular, or attended any of these sort of WoodSolutions webinars or seminars in the past. But Professor Aria Caciotti, his paper here, really good sort of overview of timber concrete composites, and from and sort of long-term testing done as well. So the long-term behavior and a bit of an understanding there, as long as just the general basics and approach to design and things to consider. And then also Design Guide 30 from WoodSolutions. So Professor Keith Cruz and Dr. Christoph Gerber. It's sort of a rehashing of lots of the work that they've done and the papers that they've produced in this space as well. Also, Dr. Andrew Buchanan's got a whole lot of information out there as well that's really, really insightful, and will give you the tools you need to better understand timber concrete composite design. For the most part, to determine your effective section properties, the most common way that I'm aware of is to use the gamma method. So looking at each of your different materials and layers and how they and using your modulus of elasticity and that modular ratio to determine effective sort of widths or the interaction and the section properties from that, and considering the interface between the different materials and different layers. So what happens at each of those joints and how much composite action can you get? So how much slip ultimately are you getting through the connection at each of those interfaces? So tributary width, this is pretty much only really applicable to the ribbed type solution. So you can use AS 3600, the concrete structures code, or AS 2327, the composite structures code there, and determine the effective or tributary width of the concrete topping slab. I guess just to pare it back a little bit further, it's probably obvious to everyone, but the reason that the conventional way to do timber concrete composites with the concrete at the top, timber down the bottom, we all know concrete's very good in compression, not so good in tension. Timber has relatively high tension or strength in tension. So having that down the bottom and your floors being loaded out of plane, you've got your compression in the top fiber, tension in the bottom. Using these methods, you can determine that tributary width. Everything I've ever looked at means that it comes down to your joist spacing, because when you're looking at it from a practical perspective to keep your floor system as shallow as possible, your joist spacing reduces, and that also factors in to just a manufacturing sort of DFMA approach as well to what's practical for assembly, for transport, all of these things. So more often than not, you'll find that the tributary width is equal to joist spacing in these things. It's worth mentioning though that the more panelized type systems and composite panels don't really take advantage or capitalize on that concrete topping slab because it's done per meter width, so you're not getting the full benefit of that material. You can introduce sort of void formers or things like that. Most of the time it's not so practical. Nick Hewson will talk about Viridi's system, which actually in a way capitalizes on that, but you've got to keep in mind you're adding another material in there, another sort of interface, another line of connection in most applications. So in a lot of ways, sometimes that becomes, it's impractical to go down that path. So what's the aim? The aim is to get sort of composite action out of these systems. So on the right-hand side, that's, you got full slip effectively. So no composite action. They're all working independently and just transferring load directly to each other in bearing, so to speak. Partial composite action, which is where most things will land, or nearly everything, with conventional type shear connectors or sort of shear key, your bearing notch type approaches, and then full composite action. So effectively zero slip, which is what you see with adhesives, and think of glue lam. You can treat that as a sort of solid section ultimately, because you don't get that slip at the joint or the each lamination or lamella. The team at Ash just shared this morning, actually, which is really good timing, is a company that's in Switzerland, so ETH Timber, that have just released some testing, haven't released all the results, but they're claiming to have achieved full composite action with just purely adhesive between the concrete and the timber. Danny Watson in-house, he actually did this sort of stuff as part of his thesis, and he has shared with the team that this works well for a controlled environment like a lab or factory environment, but which means that you have to do the full prefabrication, including the concrete. Otherwise, you can get issues of when you're pouring the concrete that you displace that adhesive, and therefore you don't get a consistent bond, and there's obvious risks with that. So very hard to achieve. Very keen to see the results of this and also understand if they've assessed the long-term behaviour and whether that glue line holds up with long-term effects creep and movement in service. In general, shear connectors, whole suite of those, so screws, whether they're perpendicular, incline screws, shearings, notches, or some sort of indentation to get that sort of shear key effect, a combination of screws with shear keys, nail plates, epoxied connections, epoxied plate connections, the list can go on. And this will give you a whole, variety of sort of load displacement curves, as you see on the right-hand side here. So you might have really high stiffness, high ultimate load, but no ductility, or lower stiffness, lower ultimate load, high ductility, somewhere in between. Really important to look at that from a structural performance perspective, but once again, the FMA principles have to come into play. And you really need to look at cost and ease of assembly of these connectors, the machining requirements of anything. So looking at notch type systems, great, but at the same time that introduces a whole lot of machining. So that could be less cost effective, more time consuming. So getting that balance right is really crucial. As part of the NIFB project, we've done a whole suite of testing of a variety of shear connectors. Apologies, by the way, hopefully the external sound isn't coming through, but there's some construction works going on next door. Hopefully it's just me that has to put up with it. So we've done a whole range of testing here to assess the performance from a stiffness and strength perspective of different shear connectors. And just wanted to highlight this, that in order to get your serviceability stiffness and your ultimate stiffness, there's lots of methods, or a variety of methods to do this, but a very common one is to use 40% and 60% of the ultimate strength. This is all elaborated on in the WoodSolutions design guide, as well as other things for everyone's information. I would argue that the reason we haven't seen a whole lot of timber concrete composites to date locally is because contractors don't want to build something on site only with no prefabricated elements. It just rarely is very cost effective, especially in sort of the mass timber space. They're very synonymous, I would say, mass timber and prefabricated solutions. So now that we're getting, some of the suppliers and manufacturers developing these systems, that's where we will guide, I guess, the market on the most cost-effective or just efficient solutions in terms of sheet connectors, rather than an engineer, for example, picking something to suit purely structural performance and not factoring in all of the other components that go into good DFMA. So worth mentioning. Sort of quickly highlight a couple of examples. Life Cycle Tower in Austria. This is that rib-type solution. So you can see here, fully prefabricated, which is where Europe has tended to go by all reports, so including the concrete there, which maybe the local market will guide us to push into that space. Bridges, like this one here, the Aga River Bridge, Timber Concrete Composites started in many ways in this form. This is some of the first uses of the system. And as I mentioned earlier, the RMIT Garden Building. This is a beautiful, just a beautiful building in general, but really good showcase of what's possible with a rib type solution. This is very much the ATC approach. Credit to back then Timber Imagineering, but Rob Nestick, the TGA team, in current days, great job in designing and also assembling these and doing all the prefab. Don't quote me on this, but I don't believe they would change the way they did it with the fully prefabricated solution, including the concrete. Whether or not they prefer to just do it on site or just change some of the ways. I'll let people get in touch with Rob. Also, should have mentioned Rob Nestick earlier. He has a wealth of experience in this space with Timber Concrete Composites. Wrapping up, so good timing. Reiterate, just put this here, all of the benefits of ATC. So for anyone that thinks this could be a good option for a project that you're involved in, please reach out, or for any mass timber jobs in general, please give me a call. Thank you.
Perfect. Thank you very much for that, Nathan. I've got a few questions myself, but we'll save them for the Q&A at the end. Just to remind everyone who got questions, please stick with the Q&A box and we'll go through them at the end. So now, without any further ado, we'll head over to Nick and hear about his and Viridi's approach to timber concrete composites. Take it away, Nick.
Nick, thanks for the invite to participate. It's been a long journey, I suppose, we've been through it at Viridi with the development of our strong floor. I'll walk you through that now, but just a quick overview, the obligatory 2-minute sales pitch for Viridi. So for those of you who haven't heard of us, we're a relatively new company. We've been operating about 3 years now out of a factory in southwest Sydney. Primarily, our sort of internal capability is focused around lightweight framing, so prefabricated walls, floors, roofs, servicing a variety of different project typologies, from schools, defence buildings, volumetric modules as well. So really taking that lightweight prefabricated framing components along with other mass timber and composite products and offering a range of solutions to the market for different building typologies. But what sort of wanted to explain today, like as a sister company to Viridi, which you guys will start to hear about in the next few months with Composite Systems. So if I could kind of explain differently, so Viridi is the kind of delivery element. So they're the ones that you go to for the quotes for the solutions. So we will provide you with lightweight framing options with mass timber, with composite, and work together with the designers and the clients to come up with a cost-effective and fast to build building. Composite systems is a manufacturing side, so primarily it's about taking timber and adding other products to make it better effectively. So the first product in that stable is Strong Floor. I'll show you a sneak peek of the next one coming up at the end of the presentation. But it's sort of born from an experience, particularly on the construction side of the benefits of timber, but also some of its limitations, and how do we use other materials to supplement the timber and help it stand further, take more load, work better in fire or for acoustics. So Strong Floor, which some of you may have seen, but it's gone through a couple of projects. I'll show you a timeline in a second, but it was a real kind of the genesis from Strong Floor came from this experience with other mass timber buildings earlier in the career of a lot of people at Viridi. So there was a lot of requirements for additional screed, additional toppings on the floor to meet acoustic requirements or for vibration. Spans were relatively limited to about 6 meters. So what we were looking to do was come up with a floor system that could answer some of those questions. And it occurred to us that, by putting the timber topping in there and getting it to work for us structurally, we could get better acoustic performance, we could improve the structural performance, and also significantly improve the fire performance as well. We see this floor system as not necessarily competing directly with the likes of CLT, but this is something that, a floor system that we could see in 40, 50-story commercial towers as people look to decarbonize their buildings. So we've been going at this for a while. So I put this together at a meeting the other day for our CEO, Adam Strong, who some of you may know. And he was quite shocked to sort of think that actually we started this in 2019. That's when we started the development process, working with WoodSolutions over in Christchurch, looking at different options, different ways to make this happen. We've gone through a testing and fire testing program and some pilot projects, just gone through a second round of structural testing. So we're well into the development of this. It's been going for sort of 3 or 4 years now as we've improved the floor, done more testing, learned from those early projects. So we're really ready, really hitting the ground running now. So design guide, if anyone wants the design guide, it's available from our website. I've probably asked you to hold off doing it for the next couple of weeks because we're about to put through a big update that captures a lot of the latest structural testing. We've made some big improvements in the system, which I'll touch on briefly. There are essentially 2 versions of the floor. So if I could explain it as it's kind of like a composite metal deck that the likes of Pondek or Fielders, those sorts of products. It's a composite metal deck with an integrated glue-laminate bottom plate. So those 2 plates are nailed and glued together in the factory. We deliver the units to site as the timber and steel component. Then the reinforcement and concrete poured on site to create a full composite system. So there are 2 versions of it, depending on the size of the channel. So the 275 floor spans up to about 6.5 meters, and the 375 floor spans about 9.5 meters. That's fully unpropped, so no back propping on any of that, which is a significant advantage when it comes to construction speed. So these are the new span tables. We've sort of presented them for different deflection limits. So for your sort of average domestic or a residential building or school building, we're capable of spanning up in the sort of 9 meter area, which is significant benefit over some other floors like CLT. So the ability to sort of achieve those sort of 9x9 commercial grids has been a bit of a holy grail for the timber industry for a while. So utilizing other materials alongside the timber, like concrete, like steel, means that we can achieve that and meet the expectations of the market. So the structural testing, as I said, has been a pretty extensive period. We've gone through two versions of the floor now. So we've done full testing of the floor, both as it's in its sort of steel and timber, and in the full composite version. We've done cyclic testing. We've done a year's long-term deflection testing, looking at creep and slip under sustained load. We've looked at testing for the lifting and as a fall arrest system through the floor as well. So there's a pretty extensive body of knowledge that's gone into the span tables and capacities presented in our design guides. It's a range of standard details that we can offer for the project. So we've gone through a lot of standard connections to glulam, to steel, to concrete. The one on the top left is the delta beam, which I'll show you in a project towards the end, which has been a really good system for us. The NCC compliance is helped through that with a product technical statement, or PTS, which is a document that we can provide for certifiers, which goes through all the relevant clauses of the NCC and highlights how the floor complies with those. So the product compliance in particular, is becoming a more and more complex challenge. Every year at the moment, it seems to get harder and harder. So we've really invested a lot of time and effort into providing the most amount of testing, the most amount of support that we can to specifiers to help through that process. Fire performance is obviously very critical. So we've gone through a range of fire tests of the floor itself, also of various penetrations for pipes, for cables, for ducts through the floor. So that's been a really lengthy process to try to complete those tests and develop those details that are robust, that we can then certify. One of the benefits of the floor system is the fire performance. So there are the floor itself with no additional reinforcement in it will achieve a 90-minute FRL. So that glulam plate will pretty much burn away after 90 minutes, and you're left with the concrete and steel section. And that is capable of supporting the load in the fire case, which is reduced over your normal ultimate floor case. If you want to get a longer fire resistant period, we can do that by either adding in additional reinforcement into the troughs, or by adding a fire rated plasterboard to the underside. So obviously the exposed suppete for an hour and for 2 hours is quite a challenging fire resistance period. But the benefit of the strong floor is that once the timber's burnt away, we've limited a lot of our combustible material. There's been a lot of challenges around particularly commercial buildings in the market with the idea of burnout, of self-extinguishment. What happens in a timber building if a floor or a compartment continues to burn? Does it ever stand the chance of going out on its own? It's a very difficult thing to prove. I know, because I've spent a lot of time in the timber industry having these conversations and trying to do testing. modeling. Our floor system, the timber effectively will function as a form of fire protection. So, providing the same sort of impact as putting multiple layers of plasterboard on there, and then the concrete and reinforcement can still support the load on its own. So this is why we see the floor having some benefits in those higher rise buildings where firefighting is more difficult. They want that ability for a fire compartment to be able to self-extinguish once the fuel is burnt out. So as I say, we've got multiple tests and assessments on the floor on itself, on service penetrations. We've got a testing program that's still continuing to grow and develop. My experience of fire testing is that it never finishes. There's always something more that needs to be tested. We're doing some new tests at Warrington Fire coming up in the next few weeks, looking at interfaces between the strong floor and different components. This one on the bottom right, in particular, being lightweight load-bearing walls. So, whatever kind of structural systems you choose, those joints, those interfaces between each are absolutely critical for fire performance, and that's something that we're very committed to continuing to test and working with the market to develop solutions for. Acoustic performance. This is a really big benefit for Timber Concrete Composites. The image on the left is from the WoodSolutions guide into CLT floors and acoustics. There's not a floor in there that offers both an exposed soffit and a compliant floor for a residential building. It's incredibly difficult to achieve to do that. So either if you want to expose the soffit of your floor and see that beautiful timber underneath, typically you're going to need either a significant concrete screed on top or a battment created floor on resilient mounts, which can be very, very expensive. So one of the key benefits of a TCC floor is that concrete layer on top, providing a much better level of acoustic performance, particularly in the low frequency, which is where timber tends to perform fairly poorly. So we've gone through a testing program together with CSIRO, looking at the floor system with a variety of floor finishes, and we saw a lot better performance at that low frequency. The concrete topping just really kind of supplementing where the timber performs badly. So we have in our design guide, we have a range of different floor build-ups for the two floor types. So, the bare floor, strong floor itself already achieves an RW50 on its own with no lining. So you need a very limited amount of finishes on top to get a very high performing concrete floor. So we see a lot of interest for this floor system in offices and in hotel or apartment style buildings where people are looking to expose the timber and celebrate the material, but not have to put in drop ceilings and things to comply with acoustics. So this is something that's pretty unique to TCC floors and to our strong floor. I think it's a really strong benefit. The floor build-ups on top are expensive to achieve that in CLT. So I just want to run through some project examples. So this is the first one I show you is our project Oak Hill College in Sydney. So here we are making the strong floor. So we bring all the glulam in from Haslacher in Europe, which we then cut and process to size through our Hundegger. All the steel channels are custom rolled in our factory, so we have a steel roll forming machine that works off a 1.5 mil steel coil. So it rolls them in, rolls all the indents and shapes and relief into the channel, and that's what gives us the bond between the concrete and the steel. And that's been where the big improvements have come in the floor with our most recent round of testing, has been refining those ribs and those shapes to better bond the concrete and the steel together. So then the channels, the units themselves arrive on the back of the truck. We have a steel rebar that goes through that we just simply hook onto. Then it picks up those panels and drops them onto site. So this is the lower ground floor at the Oak Hill project. The sort of beams running top to bottom in that center image are delta beams, and you can see those steel beams on top of the columns which have the holes through. So that's it's a product which works really, really well in collaboration with our floor. It has the reinforcement for the concrete beam sort of is pre-installed within the ribs, and that acts like a permanent piece of formwork. So what it allows is a really high capacity connection, but also a completely flat seat. So there's no downstand beams. It's much easier to run services through. You're not having to coordinate, drill holes through beams and things. That was a real success on this. Probably by getting around it, the concrete floor is still a concrete floor, so it's still kind of messy. What did surprise me on this one was it, it didn't leak. So we did a really good job of sealing around the strong floor and around all the supporting structure. So there was no significant leaks through the system onto the timber beams below. Here's the sort of final outcome from below. So you see the steel beam, the strong floor will have a really, just a big open expanse able to service very easily. So you can see a comparison. So there were some blue line beams in there which had holes for services, and you see the central corridor down the spine had a delta beam through the middle, so they could run the main ducts and cables all through that space, and then branch up into each individual classroom or lab. It was recently opened about a month ago, so working together with FBC Construction, BDN Architecture, it was a really beautiful building, and it matched up well with its concept. I should also mention that we've already supplied all the elements for that, for all the glulam, all the steel work, all the CLT, all the lightweight framing and roof. So integrating all that together with the floor system is a real strength of the business. Just going to show you, this is Picnic Point. This is another school that we did. This is a primary school in Sydney. So this is just a little time lapse again. See the prefabricated walls going in on stillages. So those were all prefabricated in our factory in Campbelltown. They were all 2R fire rated, so they needed a lot of build up and very complex cladding patterns on them. And you see the strong floor going in for the first floor here very, very quickly. That was together with some delta beams and load bearing walls. And the whole building went up in a couple of weeks on a very difficult to access site. So it worked very, very successfully. So you can see the first floor walls going in, and then we had a series of lightweight roof cassettes which went on top of this, and then so the whole building was done in a few months. So this was together with Quasar Construction and Schools Infrastructure New South Wales. So we're seeing a lot of excitement in schools infrastructure around this sort of form of construction, and we're going to see a number of projects coming up. We've got one starting in next month, which will be a 3-story version with strong floor and a combination of mass timber and lightweight walls. So yeah, just in summary, strong floor. It's here, it's available, ready to specify. offers some significant advantages, particularly that sort of longer span range, excellent acoustic and fire performance, and no temporary propping. So it's a very quick material, a quick system to install. And a short plug. So this is the next project, the next product in our composite systems range, which will be strong beam. So it's a kind of band beam version of the floor. We've just undertaken some testing, which has gone very, very well. We're going to be starting to release information to the market, but this will be ready to specify in the next sort of 3 to 6 months. So if you have any projects that would benefit from a kind of thin profile system like this, please feel free to get in touch. Thank you.
Excellent. Cheers, Nick. No, it's awesome to see this development. Obviously balancing the desire for a thin floor with the desire for a beautiful timber floor. That presentation from both yourself and Nathan has simulated a bit of conversation, which is fantastic. There are a couple of questions that are open. We'll go through those first. Nathan's done a good job of answering some of them already in the chat. So if we don't get to those already answered ones, make sure you check those out later on. But to begin with, first question is, hey Nick, can you run services in the void between the timber and the concrete?
That's one of the next pieces of R&D that I've got on my list to work on. But currently, it would be easy enough to do. It's about developing the right solutions. So we like the idea of potentially using those as kind of air plenums, and using that to potentially deliver air into spaces and to cool structures in the nighttime, things like that. So yeah, that's definitely something that we are working on soon. It's about working at the right systems and the right details and the right fire rating details to deal with that. But yes, absolutely, it's something that
it seems like a fantastic opportunity given that you had that space in there, which is a surprising side effect of this compression and the whole floor depth that you've found. Next question is also for you, Nick. It's, would on-site repair be possible for a strong floor that's had the CLT burn? Now, we do get these questions somewhat every now and then, but the burn question, I don't think it's ever happened in practice yet, certainly not in Australia. Do you think that would be feasible? Obviously, given some parameters and assumptions.
Look, it's not a question I've had yet, but it would depend on the severity of the fire, I think. If we had completely burnt away all the timber and all the protection, I think it would potentially be difficult. The floor would tend to deflect a lot if all that timber was gone. But if it hadn't, I've certainly seen some really smart repairs of CLT type floors when there has been some burning on them. So routing out, cutting out those sections that have been burnt, and then repairing those with adhesive and mechanical fixing. So I think it's certainly possible for a lot of normal fires. But if the whole timbers burn out, I think it would work for life safety, but we'd probably be looking at replacing large sections of the floor. It would be very similar to if it was a concrete slab, most likely.
Okay. I've got a question for you, Nathan, about the prefab ash TCC, which is, how do you go with the tolerance differences between the CLT and the concrete in your prefabrication process? Do you have to cut down the concrete as part of the assembly, or how do you handle that?
So current the stuff that we're working on for ourselves, and then the schemes we're doing for projects that haven't actually gone into construction phase or anything yet, but we're looking to just prefabricate the cassette. So we're using that lost formwork in ply. So we're looking at standard 2400 by 1200 sheets of ply. Therefore, you end up with sort of your 3 joists, similar to other cassette systems, tech beam, posi strut type cassettes, where you then overhang that sort of plywood in this case, or that flooring to then land on the adjacent joist. So we're working to that sort of 2400 wide cassette. And then the idea, much like Nick just showed there, with that example, pouring the concrete on site so that you're not having all of those joints. So it's not a fully prefabricated system inclusive of the concrete in these early stages. And like I mentioned, whether or not the market pushes us towards that in that direction, like is being seen in Europe, time will tell.
I certainly think, like, just to follow on from that, like, there's been a big push towards design for manufacturing assembly in the last few years. Seeing a lot more discussion of design for disassembly now. That's becoming, if not a requirement, certainly talked about on more projects. So we're working on a project at the moment, the one that we're just about to do, this 3-story school that was going to have a fully demountable bay. The client ended up kind of not pushing it on this one, but it will come on the next one. So we'll be looking at precast strong floor and demountable connections for the timber. Certainly becoming a much bigger topic than it has.
Yeah, and likewise, we've done similar things for projects where we've explored those options, and it seems we've got some ideas of how to do that. So there will be opportunities to do exactly that with our system as well.
That's good. So I'll take some questions. There was one there. Rob's asked, was strong floor source CLT from Australia at some point? The answer is yes. We've just completed some testing with the XLM CLT. We will be working towards releasing an updated design guide that will include that. So the current floor is glulam from Maslaker, so it's sort of strongly one-way spanning. The CLT version won't go quite as far, but from the results we've got, it's probably around 5% less spanning capacity for the CLT version. So certainly offers some more options and ability to introduce things like timber treatment or some other benefits of CLT as well. So definitely on the cards and something that we'll be doing the design for in the next few months. Amanda, she's asked, how is self-extinguishment demonstrated? I don't know, we've only got a couple of minutes left, so I'm not sure how we can get into self-extinguishment, but there's been a lot of work done around the world in the last couple of years. University of Queensland did a lot of testing on self-extinguishment. It's a tricky thing to demonstrate with timber, particularly with CLT. It often depends on the adhesive. I guess my comment around self-extinguishment would be much more around our floor system, which once the timber's burned away, there is no more fuel there, and the steel and concrete can't then sustain the fire, provided the rest of the fuel on the floor is burnt out. But I'm sure there's a longer answer to that talks more about the mechanics of self-extinguishment. But
it's also how you define self-extinguishment. So on the surface, it sounds as if there has to be completely no smouldering, for example, no sort of slow charring at all. But that's generally not how it's defined from a fire engineering perspective, based on my experience anyway.
Well, all right. We now reached the end of this webinar. Thank you so much for joining us, Nathan and Nick. That was really insightful. I learned a lot about timber concrete composites, and I'm excited to start seeing these things plugging the gap in the market of longer span timber structures in the wild. Before we wrap up, I'd just like to draw some attention to the Timber Design Awards for 2023 are now open. So if you have any projects that use timber, can be cladding, can be mass timber, can be studs, make sure you get those projects into this year's awards. We also have I'll just turn my video off because it's not having too much fun. We have a seminar in Sydney on the 27th of June. So make sure that you attend to that. It's a small cost, but there's some lunch and food as well. So it's a fantastic way to meet some of your local professionals and hear from some of the best about the latest in timber construction. The next installment in this WoodSolutions webinar series will be on Tuesday, the 4th of July on new innovative software, taking structural design timber to new heights, which will be between Alistair Woodard and Adam Jones. So make sure you get on the newsletters and block out that time. That's going to be a fantastic conversation. So thank you so much for joining us, and we'll see you at the next webinar. Thank you.